Section 3.4, solving multi-step inequalities. All we have to do is remember that we solve inequalities in exactly the same way as we solve regular equations. Undo what was done in reverse order to solve for that variable, except for one small catch, which is to watch out for multiplication or division with a negative number. If that happens, the symbol flips. It would change from less than to greater than, or it would change from greater than or equal to less than or equal to, if you multiply or divide by a negative number. That's really the only thing you need to remember about this section. Beyond that, we graph our answers. Remembering that you need to include an open dot or a closed dot, depending on whether or not you have greater than or less than, or greater than or equal to, or less than or equal to. We also need to write our answers in set builder notation. So like x values such that x is greater than 4 or something like that. That would be set builder notation. So that's the stuff that we got to remember about this section. After that, it's just like chapter 2. So basically, we're just going to do a bunch of practice problems today. Solve and graph the inequalities. We're multi-step inequalities here, so remember that we want to get the variable by itself, or if we can't do that right away, get the variable term by itself. So in this case, what am I going to do first? Subtract 9 from both sides. And that gives me 4t. I don't flip the inequality here. Greater than 12. Now what? Divide both sides by 4. And we get t is greater than 3. The directions say solve and graph the inequalities, so we solved it. Let's put that in set builder notation. It's ready for it right now, so we just go such that with a t in front, the squiggly brackets, and then we draw our graph. Put the 3 right in the middle, a number on either side. Now what? Open dot, and we're going to shade to the right. Not too bad. The one below it, what are we going to do first? Subtract 5. That's a positive 5. I want it to turn into 0, so 5 minus 5 is 0. We subtract 5 from both sides. And that gives us negative 9 on the left is less than what on the right? Good. See that negative sign? That's a negative 3n. Now what? Divide both sides by negative 3 to get n by itself. And that gives us what on the left? Positive 3. What on the right? Just n. And my inequality is, it's less than right now. Do we have to switch this one? Yeah, we have to flip it because we divided by negative 3. Anytime you multiply or divide by a negative number, you have to flip the inequality. So it's now greater than. I want to put that in set builder notation. Can we do that right now? No, it's in the wrong order, so we need to read backwards. Right now this says 3 is greater than n. I want to read backwards and say n is less than 3. Now it can be in set builder notation. And now we can graph it. 3 here, 2 here, 4 here. The dot will be open. And we're shading to the left. That's the correct answer. Okay, the third one, what do we do? Add 7 to both sides, good. And that gives us what? Okay, good. And now what? Divide both sides by negative 6. What does that give me? Positive 24 divided by negative 6 is negative 4. And I divided by a negative number, which means I have to flip the inequality. So it's now greater than or equal to. Okay, can I make that set builder notation? Yeah, it's ready for that. So squiggly bracket, A such that A is greater than or equal to -4, squiggly bracket. Draw my number line. Dead center goes -4. Something on the left will be -5. Something on the right would be like -3. Now what? Close dot this time. And shading to the right. Greater than is to the right. Okay, the last one, what do we do? Subtract 30 from both sides. 20 is greater than 0.8x. By the way, 0.8 is as a fraction would be 4/5. As you reach for your calculator and divide both sides by 0.8, which is fine, you'll get the same, you get the right answer. You could instead realize that 0.8 is 4/5, and then instead multiply both sides by 5/4, and then you can do the problem in your head. You get 25. But if you divide both sides by 0.8, which is what you guys are trying to do, what do you get? 25 is greater than x. Can I put that in set builder notation? Okay, so read it backwards and you write x is less than 25, and now that can be put in set builder notation. What? Graph it, okay. Draw the number line, and 25 in the middle. You want to put 0 over here? Okay. So then let's put 50 over here. It doesn't make any difference. You could go 24 and 26. Okay, my dot will be open, and I'm going to the, that says less than. I'm going to the left. Read the answer out of this format here. This says x is less than 25, less than values are this way. Okay, a little break from everyday old inequalities to solve. Take a look at this garden right here. You want to fence in a vegetable garden that's adjacent to your friend's garden. Your friend's garden probably attracts a lot of deer, and you're tired of the deer coming into your garden or something, so you're putting a fence up. What are the possible lengths for your garden? So here's your new garden right here. You're trying to fence it in. You have your friend's garden right here. You got a dimension right here of 12 feet. So notice what shape is this garden. It's a rectangle. So this side right here would be how long? 12. This side is 12. How long is the garden this way? We don't know. That's what we're looking for. What are the possible lengths of your garden? We don't know. So that's going to be our variable. We'll call that x. It says you have at most 42 feet of fence. And we got to put a fence all the way around this thing. So all the way around a shape is called what? The perimeter. We're looking for the perimeter here. To find the perimeter, we just add up all the sides. What's this side? So it's x. So we have x plus 12 plus x plus 12. And it says we have at most 42 feet of fence. Yep, so 12 plus 12 is 24. Add the two x's and you get 2x. And we have at most 42 feet of fence. So I can't go over that. So we have to say less than or equal to 42 feet of fence. Okay? Now we just solve. Subtract 24 from both sides. And we get 2x is less than or equal to 24. No. I'm reading the wrong number. 18. And then we divide both sides by 2. And we get x is less than or equal to 9 feet of fence. So 9 feet for my length, less than or equal to 9 feet here. There you go. Another problem, you want to make a rectangular banner. What's a banner?
Thing that has words on it.
Yeah,
Paper.
like a page out of a book.
No, larger
Like a large sign that goes over the top of some stuff. Okay, good. Yeah, like that over there. A rectangular banner that is 18 feet long. That's pretty long. You have no more than 48 feet of trim for the banner. What are the possible widths of the banner? Well, it's a rectangular banner, right? So I'm going to draw a rectangle. There's my banner. It has to be 18 feet long, so that's going to be this. You have no more than 48 feet of trim for the banner. So, yeah, well, what does it mean by trim? What's trim? Yeah, that's like if I put a little, some sort of little thing all the way around the outside of the banner, that would be trim, okay? So we're going to, I don't know what it's going to be, some sort of confetti or lace or, I don't know, strings, trim. So we have 48 feet of trim. What are the possible widths of the banner? So we don't know how wide the banner is. And it's just like the last problem. It's a perimeter problem. So what will I write? 18 plus 18 plus x plus x. And we have no more than 48 feet of trim. So we have to stay under 48 feet, so less than or equal to the 48. Combine all your like terms. What's 18 plus 18? 36 plus 2x less than or equal to 48. Good. Subtract 36 from both sides. Just solving for x. 2x is less than or equal to 12. And we divide by 2. We get x is less than or equal to 6 feet. What are the possible widths of the banner? Anything under 6 feet. It could be 4 feet, 2 feet, 1 feet, 18 inches. Can't be 0 or less, though. Okay? Okay, these problems could come straight out of Chapter 2, except for the fact that we're looking at inequalities instead of equal signs. But they're handled exactly the same way. So for this first one, what should I do? Distribute, and I get 3t plus 3 minus 4t greater than or equal to negative 5. And now what? Good, combine like terms. So 3t minus 4t gives me negative 1t, or just negative t, plus 3, still greater than or equal to negative 5. Okay, subtracting 3. Good? No, divide by negative 1, because we got that negative there. So we wind up with t here, we wind up with 8 here, and we had to either multiply or divide by negative 1, so the inequality flips. Less than or equal to 8. The directions still say solve and graph, so we still want to put this in set builder notation, and we still want to graph it. I'm going to squeeze in a little tiny graph right here. And my dot will be closed, and I'm shading to the less than is to the left. There's a graph. All right, I'll do one more on this page. Which one do you want me to do?
I want that one on the bottom.
This one here?
Yep.
Okay. So we have variables now on both sides. We don't have any like terms on the left. We don't have any like terms on the right. I got to get all my variables on one side, all my numbers on the other. I like to keep my variables positive. So which one am I going to move? Yeah, we're going to add 2b to both sides. And that gives me 5b plus 12 greater than 27. And look, it looks like 12,727 there. So I'm going to put a little tick mark on that 7 to make it look a little bit more like it should. Now what? Okay, subtract 12 from both sides. Five b is greater than 15. Now what? Divide by 5. B is greater than 3. Okay, set builder of that thing. A little line. Put a 3. Put a 2. Put a 4. Open dot, you're right. And which way are we going? Greater than is to the right. Okay. The other two are for you. Looks like we're going to have to distribute. Looks like we're going to have to do kind of the same thing here. Go ahead. These two here. Just these two. All right, let's take this top one here. What am I going to do first? Subtract 3n from both sides, and that gives me 8. And then I'm going to add 1, and I get 9. And then divide by 3, and it's greater than 3. Set builder notation, and then, and my dot will be? Nice. Good job. Next, what do we do? Distribute, so we get? Good job, minus 14. Remember with that minus sign in front, right there, that is a negative 2 that's being distributed in, so it's negative 2 times 4m, which is negative 8m, negative 2 times positive 7, which is negative 14. Okay, we have like terms. 5 minus 14 is negative 9, minus 8m. Now what? Okay, add 9 to both sides. Good. Remember the sign goes with the number. We divided by a negative. Negative 3. M. So we got to read this backwards. And now we can put that in set builder notation. And then we can draw the graph. I have negative 3 in the middle. Put negative 4 here. Negative 2 on the other side. Close dot, and we're going less than is to the left. Take a look at this first problem before we start solving these. What am I going to have to do here first? Distribute. Good. And then after I distribute, I'll probably have to... Okay. How about on this one? What do I have to do first here? Combine like terms. How about on this one? Distribute and then probably combine like terms. On this one? Just start solving. We don't have any like terms. How about on this one? Combine like terms. How about on this one? Just start solving. Okay. So pick one. The bottom one on the right? Bottom right, I hear. It's easy? What are we going to do then? Subtract what?
You add the 7n.
This is a positive 7n though already.
So you subtract it. Well, no, because you want the variable to be on.
Oh, that's a good point. Remember that we want the variable to be over here eventually, right? Yeah, so either you put the variable over here and then you got to read it backwards in your answer, or you put the variable over here and then you got to divide by a negative. So one way or the other, you're going to have to do something else extra. Okay. For me personally, I still like making my variable positive. So for me, I am going to still subtract the 4n from both sides. If you chose to do the other way though, there's absolutely nothing wrong with that. So I draw my line. That's not a line, but it doesn't matter. 2 is less than 3n minus 13. And now we add 13 to both sides. 15 is less than 3n. Divide, and we get, got to write it backwards, n is greater than 5. Put it in set builder notation now. Five, 6, 4, open dot, to the right. There you go. Pick another one. Bottom left. Okay, first thing we got to do. Combine like terms on the left side. Do we have any like terms to combine? No. So we rewrite it. On the right side, you get 6x plus 2. Okay, now what? Subtract 6x from both sides. So I get the variable, I guess, on the left. 8. 6x minus 6x is gone. Greater than or equal to. 6x minus 6x is gone. 2 is left. Okay, so my variables disappeared and I'm left with 8 is greater than or equal to 2. Is that true? Is 8 greater than or equal to 2? Yeah, always. So if you get something like this, where the variable disappears, and you get a true inequality, then the answer here is always true, which means what? So the answer normally would be, what's that symbol?
Always right.
All real numbers. The answer in set builder notation would be x values such that x is equal to all real numbers. Oh, that's like a squiggly bracket right there. And then the graph, this is the only time when you will actually shade your number line, because we don't have any other way to represent that number line. The graph is the entire number line. We're 1/3 of the way there on this page. Pick another one. I heard right top. Right top. Over here. What are we going to do first? Combine like terms. 6m minus 5 is greater than 6m plus 7. Okay, now what? Subtract 6m from both sides. And we get is greater than 7. Negative 5 is greater than 7. That's false. So therefore, we are going to say that there is no solution. There's no set builder notation for no solution. It's just no solution. But if you were to have to graph it, that would be your graph. There's nothing that works. So we don't do anything to that number line. Okay, we have 3 left. Pick one. Top left. All right, what are we doing first? So we distribute and we get 10 minus 8a greater than or equal to 10 minus 8a. Well, look at how that's written. 10 minus 8a is greater than or equal to 10 minus 8a. Yeah, we have exactly the same thing on both sides, and it does say greater than or equal to. Well, obviously, this is equal to itself over here. So do we have a situation where we have all real numbers as a solution again? We do. So this is all real numbers again. All real numbers can be plugged into this, and we will always wind up with a true statement. We do have to say real numbers because, believe it or not, there is such a thing as an imaginary number. Imaginary numbers are real, but they're not. But they exist, even though they don't. So that's why we have to say real. Okay? So the answer is all real numbers. I can put that in set builder notation. A values such that A is all real numbers. And again, I can graph it with a number line and just shade the whole thing in. There you go. All right, pick one more.
One over there.
The one over there. Which one's that? The one in the middle.
Yeah, and I pointed to it.
I don't know. I can't tell where you're
One over
pointing.
there next to you, close.
The one closest to me? Where am I?
Right in the middle.
Right.
The one on the right.
Yeah,
All right.
five out.
So what are we going to do here?
Find my time.
Okay, like terms are combined.
And then you
Subtract
subtract 5 out.
5n from both sides. N is less than or equal to -1. That's false, so there's no solution here. If you had to draw a number line, there'd be nothing on it.
Do you have to be on the man?
I wouldn't, unless it asked me to.
Is there such thing as a set builder notation for those
No, that's it. Actually, that's not quite true. We haven't gotten to this yet, but in this chapter we'll talk about the empty set.
Oh, yeah.
You've seen this symbol before representing no solution. So this is set builder notation here, and we're just calling it the empty set. Okay? And the last one, this one apparently looked really scary. We didn't want to do this one until very last. Distribute and we get okay, now what? Combine like terms. Now what? You thought you'd what? No. These are all on one side of the inequality. So that's combine like terms. So we add 2 to both sides. Now what? Divide both sides by 5. T is less than 4/5. That's ready for set builder notation. And then we just got to graph it. Here's my number line. 4/5 goes right in the middle. What will go on the left? You could do 3/5. Or if I wanted an integer, the first integer to the left of 4/5 would be is 4/5 bigger than 1? Is 4/5 bigger than 1? No. Is it less than 1? Is it bigger than 0? Okay. So 0, 1. My dot will be open, and I'm going to the less than is to the left. There you go. That is the entire section.